So, of course, now we got to set up the matrix if you were going to really do this. And I always ask myself, how many times these guys going to see me cut this thing up, take a random point, stick it into the function, add them, and then say from Calc 1 that leads to the integral. Well, I don't mind a redundancy if it's something that someday you'll carry with you when you're doing some other project where you're like, well, I can estimate. It always comes down to variable density versus a homogeneous solid or whatever, or even an area. So anytime you can cut something up and estimate it by taking a point and multiplying it times that distance, it's going to be an integral. And that's really the lesson. That's really what I try to get across when I do all this. Yeah, I'm trying to validate the fact that I'm going to write a double integral down. But I more think of it the other way, where you're in a lab or you're doing your work and you're looking at something, you're saying, well, how am I going to, it's variable across this whole thing. Each point has a different value, but the final value is the sum of it all. It's going to be an integral. It's going to be an integral. For you comp sci, it's going to be a lot of cumulative density functions and those kinds of things that measure how long things take and that kind of stuff. In the old days of computer science, I don't know what you're doing nowadays. You're probably taking over the world.
Not bad.
You will. You will. So total mass approximately a double sum, I equal 1 to n, j equal 1 to m, of rho of x sub I superstar, y sub j superstar, dA, delta A. And m, of course, is going to be exactly equal to the limit as m comma n tends to infinity of this guy, which by definition is a double integral over d of rho of x comma y dA. Each 8. Find the total mass of the lamina of variable density rho of x comma y equal to x squared, and I get written in here grams per square centimeters, but we don't need to say that. Whatever, the units are compatible. That occupies the region bounded by y equals 2 minus x squared and y equals x in the xy plane. So we know it's a double integral over d of the density dA. So what's d? Let's see, it's bounded by this guy and this guy. Really, it comes down to, you know, an application, but it's stuff you've already done. You need limits of integration. In other words, this guy right here is really a function different than a height function. It's just a function, like I said, it could be variable charge in a plate. Okay? You're looking for total charge. It's the exact same double integral as total charge. It's in your reading. Okay? So, let's see. So this is the integral x squared. And what do you think? Type 1, type 2?
Type 1.
Type 1. So we're going to go dy dx. Okay? The lower limit is going to be this guy, the line. The lower limit is the line, y equals x. The upper limit is the parabola, 2 minus x squared, from something to something, and that something to something is where y equals 2 minus x squared intersects with this guy. So points of intersection minus x squared equals x, 0 equals x squared plus x minus 2, x plus 2 times x minus 1 equals 0, x equals negative 2, x equals 1. Careful. Antiderivative of x squared dy. Yx squared, y, whatever you like best. When I asked for a board that would slide up and down, they told me that the ceiling wasn't big enough. I found it in a catalog. I realized they were right. But then I went back and said, couldn't they make it like a garage door where students could still look up there and see it? Yeah, they said, yeah, right.
That would be awesome.
Yeah. They threw all these blackboards away from, well, at least I heard they threw them away. I keep trying to find them from the old Sophie Finn school that they redid for Ulster. They said they threw them away, and they were the real slate. I would love to take, have like a room that's maybe, I don't know, 8 by 8, 12 by 12, floor, walls, every wall, every floor, every ceiling, blackboard. Every ceiling. Every floor. There's only one, but all 6 sides, the blackboard, and kids could go in there with chalk and draw on and go up and go over and have a little scaffolding set up for them. Nice. I'm going over here to do it. I'm trying to save that, is why I was thinking of pushing it up. So I'm going over here, and that's x squared times, that was the higher one to get the parabola. 2 minus x squared minus x squared times x. And so that's what? 2x squared minus x to the 4th minus x cubed. I only got the answer. Okay. 2x squared minus x to the 4th minus x cubed. You guys, is that right?
Yeah.
So let's see, so that's the integral of minus x to the 4th minus x cubed plus 2x squared dx from negative 2 to 1. originally interested in the center of mass. Okay? Now the center of mass we're going to refer to as y bar comma x bar, and in statistics that's called your centroid. We're trying to find where that is in this expression. And very similar to this idea, okay? There's a moment that we talk about, a moment with respect to the y-axis and a moment with respect to the x-axis. So, if I look at this picture and I'm talking about moments, let's say moment to the x-axis. We'll call it m sub x. And what it is, it's the moment is the sum of the distances times the density. I'm sorry, times the mass at each point. It's the directed distance from the axis to each point times the mass at each point. It's exactly this. So if I say the moment to the x-axis, which is denoted m sub x, and this you'll see what bothers me about this in a minute. So every point, let's suppose we took this point right here, and we said, okay, its moment is this distance times the density. So the moment in here can again be estimated by the density at this point times the area. Okay? But the question is, what's the distance? At any point in here, at any x comma y point, what is the distance from this point to the x-axis? Careful. It's what?
Y.
It's y. It's y sub j superstar. And that's the little bit of a ink, because this is going to be used for y bar and the other one is used for x bar. Where m sub x is equal to, okay. Then I go through the whole thing. You know, I partition A, B,